Hi, everyone. My name is Eugene Kawamoto, and I lead the Redshift product management team here at AWS. My team works together with customers all around the world, from fast-growing startups to large enterprises. We work backwards from customers to understand their needs and requirements and to help reflect back the feedback into a roadmap so our engineering teams can deliver innovative products and features. Today, I'm really excited to talk about what's new with Amazon Redshift. Redshift first launched in 2013 as the first cloud data warehouse to serve customers with any size, from small workloads to petabyte scale data problems. Over the past 8 years, we delivered various features such as our latest and most high performance node type RA3s, together with Redshift Managed Storage, concurrency scaling to help customers scale their workloads, and features like Spectrum for customers that want to integrate their data with their data lake. Today, we'll cover some of the innovation that has happened over the past 18 months, together with our new exciting announcements. But before that, let's cover some of the challenges that customers are facing. As we all know, the amount of data that is generated has exploded over the past 20 years. The proliferation of IoT devices and smartphones have accelerated the amount of data that is generated every day. But more importantly, majority of the data is now generated on the cloud. This is because customers can achieve instant durability and scalability on the cloud without worrying about the underlying infrastructure. Due to this trend, over the past decade, customers' data problems have increased from terabytes to petabytes, and now we see customers with even exabytes of data. And this has created even more new challenges, and we've bucketed these challenges into 3 large groups today. First, customers want to access all their data. However, data may be distributed into silos. Some may be stored as structured data, such in relational databases. Others may be stored as semi-structured data, stored in object stores, such as clickstream data that is constantly streaming from mobile devices. There are also emerging use cases such as machine learning. Second, as you do analytics on the cloud, many customers also serve end customers. These can be tens, hundreds, or even thousands of data analysts that need to finish their jobs on time with strict SLAs. Slower query performance can lead to missing these SLAs, leading to bad end-user experience. As data is increasing, customers are looking ways to reduce their operational burden. Finally, given all these challenges, our customers still need to solve this in a way that is cost-effective and also complies with your security and compliance rules. It is not simple as throwing more hardware at the problem, and customers need predictable costs, even as their workloads scale. Given all these challenges, so why have customers decided to choose Amazon Redshift? First is our lakehouse architecture. Redshift Spectrum has enabled customers to query the S3 data lake where it lives. As more customers want to query all their data, we've expanded the capabilities to query relational databases to combine with your operational data. Second, Redshift provides fast performance at any scale. Whether you're just starting or an advanced customer, Redshift provides performance and scales to your needs. Our RA3 nodes have enabled best-in-class performance both out of the box and at scale. RA3 nodes, together with managed storage, has enabled the compute and storage to scale independently. And AQUA is built on these RA3s and provides a new hardware accelerated cache to boost your queries. Finally, we have helped customers get the best value and bang for their buck. Most importantly, we make sure that your costs are predictable even as your workloads scale. So let's take a look at some of the customers that have taken advantage of Redshift. NTT Docomo, the largest mobile telecommunications company in Japan, has migrated over 10 petabytes of data from on-prem data warehouses to Redshift, where they can achieve 10x performance improvement over their legacy systems. Fox, a major media and broadcasting company, generates billions of transactions every day, coming from various third-party sources. The lakehouse approach has enabled Fox to query data where it lives using Redshift Spectrum. Warner Brothers, using Elastic Resize, helps scale up and down clusters based on their peak usage. They also use Workload Manager and set query monitoring rules to optimize their resources and maximize their throughput. Finally, they leverage the latest RA3 nodes for best-in-class performance. By working backwards with these customers, we've identified 3 investment areas. First is data lake and further integration with other AWS services and partners. Second, performance at any scale, from out-of-the-box query tuning to customers with strict SLAs that have multi-petabytes. Third, keeping it cost-effective and predictable to get the best value out of Redshift. We'll discuss further about the new and updated features in each of these investments areas soon. So let's start with diving into our first investment area with analyzing all your data. Our Lakehouse approach has enabled customers to continuously use Redshift as your primary data store and combine data with other stores without leaving your data warehouse. This can reduce the need to build additional ETL pipelines that may take even days or weeks. As discussed, using Redshift Spectrum, customers can query data from the S3 data lake. Data can be queried in common open file formats such as Parquet, JSON, ORC, Avro, and we recently announced the support for Hudi files as well. Redshift also integrates with AWS Lake Formation, so you can provide fine-grained access control. In addition, you can unload your data into the S3 data lake using the export command in data formats such as Parquet. This data can now be analyzed using other popular analytics data services such as Amazon EMR, Athena, as well as machine learning services such as SageMaker. For customers that want to access data in operational databases, we have federated queries. You can integrate queries on live data in RDS PostgreSQL and Aura PostgreSQL. We have also announced AWS Elastic Views as a way to combine and replicate data across multiple data stores as a materialized view in Amazon Redshift. Accessing all your data can be enabled through a familiar SQL interface using JDBC ODBC drivers connecting with your choice of BI and analytics tools. So let's take a look at the new features that we're introducing today. First, we're announcing the preview of Redshift ML. We've seen customers that want to use their data in Redshift to enable new machine learning use cases such as product recommendations, fraud prevention, and reducing customer churn. However, in order to do this, customers need to learn machine learning experts or to learn other machine learning services. This also involves building pipelines to move and transform the data, and also code in other languages such as Python and R in order to create and train models. Using Redshift ML, customers can now create, train, and apply ML models using SQL. Customers can use a create model command and select appropriate columns to create and train a model. Behind the scenes, Amazon SageMaker Autopilot selects the most optimal ML algorithm based on your data. Once the model is ready, the model will be deployed locally in Redshift with optimized tuning. And customers can run inferences as invoking a user-defined function as part of their SQL statement. This can all be done using SQL commands within the Redshift environment. Next is data sharing. Customers have been asking us easy ways to share data across groups, but still enable workloads to be independent with one another, enable customers to charge back each group based on their usage. This means moving data and copying data between different clusters. However, this could be cumbersome, prone to errors, and customers may not always have the most up-to-date data. Data sharing provides instant, granular, and high-performance access without copying data. Customers can query live data, constantly updating data that can be queried across all consumers. Data is shared securely and provides governed collaboration. Customers can provide access in different granularity, including schema, database, tables, views, and also user-defined functions. The architecture is built on R3 and managed storage. This also opens up to various new use cases where you may have one ETL cluster that is producing data and have multiple consumers, such as ad hoc querying, dashboarding, and data science clusters to view the same data. This also enables bidirectional collaboration where groups such as marketing and finance shares data with one another. Finally, in addition to sharing data between Redshift clusters, we will be supporting sharing data with the data lake. where live data can be shared with analytics services such as Amazon Athena and EMR. The next upcoming feature is native support for semi-structured data. We supported reading nested documents such as JSON file formats using Redshift Spectrum, but we've also constantly reviewed requests to query nested data natively in Redshift. We're excited to introduce a new data type, Super, that will support these nested data formats such as JSON and ION files. This will enable customers to ingest, store, and query nested data natively in Amazon Redshift. JSON formatted data can be stored in Super columns. This will make use cases such as operational analytics easier. We'll get fast insights with the best performance using Redshift locally. The Super data type can be queried through an easy-to-use SQL extension that is powered by Particle. Particle is a SQL language that makes it easy to efficiently query data regardless of the format of data, whether it's structured or semi-structured data. With Redshift Federated Query, customers can combine operational data that is stored in popular databases such as RDS and Aurora PostgreSQL. You can enrich your data by joining analytics data from your Redshift data warehouse, together with both operational data in Aurora as well as data from the lake. This has helped customers to gain better insights, such as performing a customer 360 analysis to understand details about a customer's purchasing behavior. And finally, we're very excited to announce a preview of RDS and Aurora MySQL support, another popular database engine that is commonly used among our customers. While we enabled customers to integrate with the data lake and with customer data sources such as RDS and Aurora PostgreSQL and MySQL, we've also received requests to have the flexibility to integrate with other AWS partners and services as well. Redshift now supports Lambda UDFs, where customers can invoke a Lambda function from your SQL queries if you're invoking a user-defined function in Redshift. You can write Lambda UDFs to enable an external tokenization of data by integrating with AWS partners like Protegrity. You can also use it to access other popular AWS services such as DynamoDB or SageMaker. Customers have asked us to accelerate their data onboarding and get up and running in minutes. They look to bring data from applications like Salesforce, Google Analytics, Facebook ads into their Redshift data warehouse in an efficient and streamlined way. With our new native partner integration in your Redshift console for public preview, you can get up and running by bringing data to Redshift, working with our partners efficiently. You can launch the partner integration wizard from the cluster details page and select technical partners that have integrated with the console. And I'd like to thank our 5 partners, Matillion, Sisense, Segment, ETLeap, and Fivetran, to be a launch partner for this new feature. If you're a Redshift partner and you'd like to be integrated as part of the console, please reach out to us at redshift.partners@amazon.com, and we'll be happy to collaborate together. So let's dive into our second investment area, performance and scale. Redshift provides the best performance at scale, at any scale. In particular, we've invested heavily over the past year for out-of-the-box performance. For customers that just started out with Redshift, you'll still get best-in-class performance. As your workload increases and your data size increases, you'll see even better performance. Our RA3 nodes, managed storage, and concurrency scaling has enabled customers to start small and grow to petabytes of workloads. And now you can use AQUA to boost your queries even further. In addition to absolute performance, price performance is one of the most important metrics that we have. Regardless of the scale of your workload, whether you're running a terabyte of data to hundreds of terabytes to even a petabyte of data, you'll get the best price performance at any scale with predictable costs. Our price performance and scale story is centered around the RA3 nodes and Redshift managed storage. First of all, with the RA3 nodes and shared managed storage architecture, this has allowed customers to scale compute and storage independently. Where you can size your warehouse only based on steady-state compute needs. The RA3 nodes are built on the AWS Nitro system with high bandwidth networking and performance that are indistinguishable from bare metal. These node types leverage high performance SSDs as local caches and leverages your workload patterns and advanced data management techniques such as prefetching your data to deliver the best performance at scale. RA3s have been provided in two sizes, the 16XL and 4XL. As we've seen an increasing number of customers adopting to RA3s, based on our customer requests, happy to introduce the XL Plus node type today. XL Plus is 1/3 the size of the 4XL and will address the needs for smaller cluster sizes. In addition, we have increased the max size of data that you can store in a single cluster, where you can now store up to 16 petabytes of data using the 16XL. Using RIs, you can get cost savings of 33% discount over on-demand with 1-year RIs and 60% for 3-year RIs. Building on the RA3 platform, we have AQUA, our advanced query accelerator. AQUA is a new distributed and hardware-accelerated storage layer for Redshift. AQUA is built on the first of its kind custom hardware for cloud data warehousing and analytics that includes AWS-designed custom ASIC and FPGA chips for the storage layer. It allows us to process common operations like compression, encryption, large scans, filtering, and aggregations order of magnitude faster than what is possible using a general purpose CPU. In particular, AQUA will be the best in processing large amounts of data close to the storage layer, so less data needs to be moving over the network, avoiding the challenges with the network becoming the bottleneck for processing data at scale. AQUA will be free of charge, and happy to announce that AQUA's preview is now open to all customers, and AQUA will be generally available in January 2021. Many customers have fluctuation in workloads throughout the day. However, configuring clusters for peak demand could be an inefficient use of resources. Also, running your cluster based on steady-state workloads means slower queries during peak times. Concurrency scaling is a way to scale out multiple Redshift clusters from a single endpoint in seconds. This happens transparently and provides you with fast, consistent performance even as the workloads grow to hundreds of concurrent queries. Additional processing power is ready in seconds and does not need to be pre-warmed or pre-fetched, pre-provisions. You pay only for what you use with per second billing. You also accumulate 1 hour of concurrency scaling cluster credits every 24 hours while your main cluster is running. Amazon Redshift continuously monitors user workloads and uses sophisticated algorithms to find ways to improve the physical layout of data to optimize query speeds and tune queries. By using automation to tune the cluster, customers can decrease administrative costs for Amazon Redshift while getting the best possible performance. These automation features are optional, and if you prefer to have fine-grained control over your performance and tuning, you can continue to do so. Our new automatic table optimization feature selects the best sort and distribution keys to optimize performance for the cluster workloads. If Amazon Redshift determines that applying a key will improve performance, tables will be automatically altered without requiring administrative intervention. Additional features such as auto vacuum delete, table sort, and analyze eliminate the need for manual maintenance and tuning of Redshift cluster to get the best performance. We'll look more into detail about the updates of Auto Workload Manager and Materialized views in later slides. So the final innovation within the performance and scalability investment area is Materialized views. MVs provide significantly faster query performance for repeated and predictable analytical workloads, such as dashboarding, queries from business intelligence tools, and ELT data processing. Using Materialized views, you can store the pre-computed results of queries and efficiently maintain them incrementally, processing the latest changes made to the source table. MVs can be manually refreshed, or you can schedule the refresh. Amazon Redshift now provides a new option to automatically refresh materialized views, simplifying the usage of up-to-date materialized views to accelerate query performance. As you submit a query, the auto query rewrite capability leverages one or more relevant materialized views and can improve query performance by orders of magnitude using existing materialized views. Materialized views can be leveraged even in cases where specific materialized views may not be explicitly referenced in the queries. Our last investment area is low cost and best in value. As we discussed in performance and scale, Amazon Redshift provides the best performance regardless of your workload size. You can start small using the smallest node for 25 cents per hour, and as your workload scales, you can also purchase reserved instance for up to 60% discount with the RA3 nodes. RIs are favored by many customers where it not only provides a low-cost way to pay for Redshift, but also a steady, predictable cost structure, so you'll not be surprised with your Redshift bills at the end of the month. We also provide various cost controls to help you maintain your budget through pause and resume, concurrency scaling, and spectrum controls. We'll start out by talking about cluster pause and resume, which lets you easily stop and start clusters to save clusters for costs for intermittent workloads. Today's analytics workloads typically require data warehouse to be available 24/7. However, there may be times when you need an Amazon Redshift cluster to be available only for a short duration of time at frequent or infrequent intervals. Examples include running a periodic ETL job for a cluster being used for test and development where it is not being used in off hours or on weekends. Pause and resume is a simpler way to suspend billing for hours at a time on a regular basis. While the cluster is paused, only the cluster's storage incurs costs. Pause and resume can also be automated using a schedule you define to match your operational needs. In addition to node and storage costs, customers can incur costs for burst workloads using concurrency scaling, as well as querying the S3 data lake using Spectrum. You can create daily, weekly, and monthly usage limits and define actions that Amazon Redshift automatically takes if those limits are reached to maintain your budgets with predictability. Actions include logging an event to a system table, alerting with a CloudWatch alarm, notifying an administrator with SNS, and disabling further usage. Here, we will discuss about how you can maximize the return on investment using workload management. Our customers run a complex mix of applications, all competing for the same database resources. For example, frequent data loading competes with business-critical dashboard queries. Each workload types have different resources needs and query latency expectations. So how do you manage these expectations while optimizing costs and performance for a data warehouse? One approach is to solve this problem simply by adding more resources. However, this approach is problematic because it leads to unpredictable spend and high invoices. Redshift WLM helps users maximize query throughput and get consistent performance for the most demanding analytics workloads. You can use WLM to define multiple query queues and to route these queues to the appropriate queues depending on the priorities at runtime. You can also enable Amazon Redshift to manage how resources are divided to run concurrent queries with automatic WLM. We have enhanced the WLM using machine learning to predict the amount of resources a query will need to pack into the system. In particular, we have made enhancement to short query acceleration, and this allows for more consistent query performance as well as more efficient utilization of resources. And customers requires best-in-class security and compliance features. Amazon Redshift offers all security and capabilities without any extra cost. For authentication, Redshift provides built-in integration with AWS IAM and uses IAM Federation to support popular third-party services such as Azure Active Directory, Okta, and Ping Federate. Redshift also offers support for multi-factor authentication. For access control, Redshift offers fine-grained table and column-level access control for both data locally in Redshift and for data lake with built-in integration for lake formation. This allows data lake administrators to define their data security policies once in lake formation, integrating with analytic services, whether you're using Redshift Spectrum, Athena, EMR, or SageMaker. Redshift audits connection events, user events, and user activity events as well. Redshift also offers built-in integration with AWS CloudTrail. For encryption, Redshift supports encryption for data in motion and at rest. For data at rest, we support encryption with both server and client encryption keys. We also support storing encryption with keys with AWS KMS. Redshift also offers capabilities to support custom tokenization or detokenization by leveraging Lambda UDFS to integrate with third-party providers such as Federated. Finally, Redshift integrates with AWS compliance programs. The AWS compliance program helps customers to understand the robust control in place at AWS to maintain security and compliance in the cloud. So our last topic for today is low cost and best value is a popular ask we have from customers regarding cluster recovery across availability zones. This is another built-in feature that will be provided for no additional cost. To support the ability to recover a cluster in another AZ, Redshift now supports the ability to relocate a cluster across AZs without losing any data or having to change your client applications. As the existing cluster fails, a new cluster is created on demand in another AZ. The cluster's endpoint remains the same after the relocation occurs, so applications can continue operating without modification. This feature is offered for the RA3 instance families with separate compute and storage resources, allowing for compute resources to move and still have access to the same data using managed storage. Redshift Managed Storage also enables RPO0 with no data loss. Today we've covered more than a dozen new features and updates with Redshift. We're really excited about how you'll be using these new features, and we'll also be looking forward to receiving feedback. It's still day one for Redshift, and really excited about how we'll continue to innovate and add new features through these key investment areas as we go forward. For next steps, if you're already using Redshift, please work with your account team to continue to learn more about what's new so you can make sure you're taking advantage of the latest features. If you're just getting started with Redshift, work with our account team for a 10-minute demo or visit our documentation page to learn more about starting on Redshift. If you're not sure about who to reach out to, you can request help from the AWS link shown on the screen. And last but not least, thank you very much for joining this session. Bye.